Now, here in Chapter 5, we want to take a look at a geometric way of doing a process called linear programming. And I won't bother trying to define it for you, but I'll show you what it looks like. You should recognize the system of inequalities that we have, only this time we have a function that we're trying to maximize. In fact, we're trying to find the maximum value of P. Think of it maybe as profit. We want to find the maximum profit. These are called the constraints. So, subject to these constraints, we want to find the maximum value of P. Now, here's what the process looks like. We're going to draw the graph of each inequality. Remember, the x greater than equal to 0 just means above the x-axis and to the right of the y-axis. So here's the region. This is called the feasible region. And we did this in the last chapter. The corner points of that region would be where all those boundary lines intersect. Some of those we can just tell from looking at it what they are. For example, the origin, 0, 0. The point here where the blue line crosses the y-axis, that would be 4. And the point here where the red line crosses the x-axis, that would be the 5. And finally, where the two lines cross. To find that, we need to take the two equations and solve them like we did back in Chapter 4 using the RREF. So these are our corner points. Now, we're going to take the optimizing function and plug each of those into the optimizing function. So our optimizing function is 5x plus 5y. So using the 0, 0, we get 5 times 0 plus 5 times 0. Well, that would be just 0. Okay, 0, 4 means we want to plug a 4 for y and a 0 for x. So it'd be 5 times 0 plus 5 times 4. That would be 0 plus 20, or just 20. The 5, 0, it'd be 5 times 5 plus 5 times 0, which would be 25. And the last one would be 5 times 4 and 5 times 2. That would be 20 plus 10, which would be 30. So the largest value would obviously be the 30. And that comes from having 4 of the x's and 2 of the y's. Here's another one. Let me point out that this one says minimize, but it's the same idea. We're going to draw each of the inequalities. Here's both of them color-coded for you. Red line, blue line, red and blue. And the corner points are already labeled. So what are our corner points? Well, this one would be 0, 8. That's where the red line crosses the y-axis. Okay. This one would be 10, 0. That's where the blue line crosses the x-axis. And finally, where do these two cross? That would be what we get when we solve the system of equations. Again, using the RREF. Now we want to plug each of those into the z function. So the first one, you can see, would be 8 times 0 plus 7 times 8. That's 0 plus 56. And so on. I won't keep writing it down. You can see we're plugging a 10 in place of the x, and a 0 in place of the y, and a 2 in place of the x, and a 4 in place of the y. Now, since we're trying to minimize, we choose the smallest answer.